picture this. It's 1959. Long before anyone is even whispering the word nanotechnology, the legendary physicist Richard Feynman gets up and gives a talk that would literally echo for decades. He wasn't just predicting the future, no. He was throwing down a challenge, inviting scientists into a world they hadn't even imagined. So today, let's dive into the absolutely mind-bending ideas from a talk that invited us all to build the future, one single atom at a time. Right at the start, Feynman basically brushed aside what people in his day called miniaturization. You know, stuff like writing the Lord's Prayer on the head of a pin. He called that a primitive, halting step. He said, that's child's play. What he was interested in was a world so staggeringly smaller that it was a whole new scientific frontier. So to prove just how much space was down there just waiting to be explored, Feynman didn't start with some crazy complex math. Nope, he started with a challenge. A really simple but totally mind-bending thought experiment that all revolved around a pin. This was his opening shot. It sounds completely impossible, right? But here's the thing about Feynman. He wasn't just trying to be provocative. He had already done the math. And his calculations showed that it wasn't just possible, but that the laws of physics were practically begging us to go and try it. Okay, so here's how the math breaks down. The head of a pin is about a 1/16 of an inch across. Feynman figured out that if you magnify its surface area by 25,000 times, you get the exact same area as all the pages of the Encyclopedia Britannica put together. So, logically, all you have to do is shrink the encyclopedia down by that same factor. And this is the part that proves it's not just science fiction. Think about a tiny little printed dot in the encyclopedia. If you shrink that dot down 25,000 times, it would still be about 32 atoms wide. Its total area would contain roughly 1,000 atoms. That is more than enough physical stuff to actually make a mark. It could be done. For real. But why stop with just one encyclopedia? This is Richard Feynman we're talking about. He immediately took the challenge and scaled it up to include, well, all of human knowledge. At the time, he figured there were about 24 million books worth reading in all the world's libraries. So the question became, what would it take to store all of that information in the same tiny way? The result is just astonishing. The total area you'd need for all 24 million books works out to be about 3 square yards. He pointed out that you could put all of that onto a pamphlet of just 35 pages. Think about that. A little pamphlet containing, and I'm quoting him here, all of the information which all of mankind has ever recorded in books. Wow. But see, just shrinking down pictures is still thinking in 2 dimensions. Feynman pushed it way further, into the realm of pure information. He asked, what if we stopped just copying pages and started encoding knowledge, bit by bit, using a kind of code made of tiny little cubes of atoms? And this is the breathtaking conclusion. Even being super conservative and using a cube of 125 atoms for every single bit of information, Feynman calculated that every word from every book ever written could fit inside a cube of material so small it would be like a speck of dust, barely visible to the human eye. Just let that sink in. Okay, so storing information was really just the beginning. The next idea was even wilder. It was about moving from passive data to active machinery, to build microscopic machines that could actually do stuff. Feynman actually credited this incredible idea to his friend, Albert Hibbs, and it's an image you won't forget. Imagine a tiny mechanical surgeon, small enough to be injected into your bloodstream. It could travel to your heart, find a faulty valve, and just slice it out with a tiny little knife, all from the inside. We are literally witnessing the birth of the idea of nanomedicine right here in 1959. Of course, the immediate question that pops into your head is how? How in the world could you ever build something that small? Well, Feynman had an answer for that too, and it was pretty elegant. He came up with this idea he called a master-slave system. You'd start with normal, human-sized controls that are wired to a set of mechanical hands that are, say, 1/4 scale. Then you use those hands to build a tiny new 1/4 scale factory. And then you use that tiny factory to build another set of hands, now at 1/16 scale. You just keep repeating the process, getting smaller and smaller, making a billion tiny factories that take up less space than one regular machine in a workshop. Okay, so all of this, the data storage, the tiny machines, it all leads to the ultimate conclusion of his talk. The ability not just to make small things out of stuff we already have, but to build completely new materials from the ground up, one atom at a time. Feynman pointed out something really profound. For all of human history, we've basically been limited by what we can dig out of the ground. We find stuff, we purify it, we mix it together, but we always have to accept the way the atoms are arranged by nature. But what if we didn't have to accept that? What if we could place atoms exactly where we wanted them? I mean, we could create materials with properties we can't even dream of today. We could synthesize any chemical we want just by assembling the atoms in the right order. We could build computer circuits so small they'd be governed by entirely different laws of physics. Hello, quantum computing. And every single thing we made would be a perfect, flawless copy. And this is where the idea takes its final, most incredible leap. Once you start building things with just a few atoms, you're not playing by our normal, everyday rules anymore. You're in the strange, wonderful, and powerful world of quantum mechanics. And that's not a limitation. That's a massive opportunity. It's a whole new playground for design and technology. Now, Feynman didn't just want to talk about these cool ideas. He wanted people to actually go out and do something about it. So he ended his talk not with a summary, but with a direct challenge to the entire scientific community. And to prove he was serious, he put his money where his mouth was. He offered 2 prizes of $1,000 each, which was a lot of money back then. The first was for anyone who could actually pull off his encyclopedia on a pinhead challenge. The second was for the first person to build a working electric motor that was only 1/64th of an inch on each side. He wanted to turn his thought experiments into real-world engineering. And this, right here, was the fundamental message of his entire talk. None of what he was proposing violated any of the known laws of physics. This wasn't magic. It was simply an engineering and chemistry problem that no one had seriously tried to solve yet, because, as he put it, we are too big. And that really leaves us with a fascinating question, doesn't it? Feynman pointed out this vast, unexplored scientific continent that was hiding in plain sight the whole time. It really makes you wonder, what impossible-seeming frontiers are we all staring at right now, just waiting for someone to come along and point out that there's plenty of room?